When working with any process, you will inevitably encounter a large number of figures, both related to the output and input of those processes. It can be challenging to make sense of all those numbers, and that is where statistics can help. Statistics is a field comprising two main branches that aims to assist with this task. There are two types of statistics, descriptive and inferential. Later in this playlist, we will discuss inferential statistics, including hypothesis testing. Let's focus on the first branch of statistics, which is descriptive statistics. Its purpose is to help us understand the data we have. Using descriptive statistics, we can gain insights into any dataset we have and make sense of it. On the other hand, inferential statistics is used to make predictions about a population based on a sample. When analyzing data, descriptive statistics can help us understand it better. There are two main aspects to consider, the measure of central tendency and the measure of dispersion. The central tendency measures the center of the dataset. It helps to understand the typical or representative value of the dataset. For instance, if you have a list of numbers, you can calculate their average to get a better sense of the data. Let's say you are looking at a house price in a particular area. You have a list of prices for several houses that are currently on the market, and you want to find out the average price of the house in that area. To do this, you can add up all the prices and divide the total by the number of houses on the list. This will give you the average price of a house in that location. When it comes to measuring the spread of a data, we use a concept called dispersion. For instance, if you have the price of several houses and you want to find out how much variation exists among them, you can use the measurement of dispersion. It will tell you whether the house prices are similar or different from each other. In other words, dispersion helps you to understand the range of values in your data. In this video, we will discuss the concept of central tendency and its measurement methods, including mean, median, and mode. In the future videos, we will discuss the measurement of dispersion, where we will cover range, standard deviation, variance, and IQR. So let us start with the mean. Central tendency is measured by finding the mean, popularly known as average. This is standard method used in statistics. To calculate the mean, add all the values together and divide by the number of data points. For example, if we have a set of 8 values, that is 10, 12, 18, 12, 12, 14, 16 and 10, we can find the mean by adding all of them and dividing by 8. Therefore, the mean of these 8 values is 13. In mathematics, the formula to determine the mean is x bar equals the sum of x divided by n, where n is the total number of data points. The sign is a capital sigma, which is used for the sum. To calculate the average, all the numbers are added and divided by the number of items. This is how we find out the mean. The mean can be problematic as it is sensitive to extreme values, also known as outliers. For instance, in a dataset containing house prices, one of the house is very costly. Let us say a single house price at $10 or $25 million would be considered an extreme value. In such a scenario, the average price of the house in that particular location would be significantly skewed by that one expensive house. This illustrates a clear disadvantage of using the mean or average to analyze the data. In our example, if the value was 120 instead of 12, the resulting average would be significantly higher than 13 we calculated in earlier example. This is a disadvantage of using mean or average. When arranging a data in either ascending or descending order, the median is the middle value. Let us take those 8 numbers for which we took mean earlier. So these are the 8 numbers as shown in our slide. So if you want to find out the median of this, you arrange them in sequence in an increasing or decreasing order. So I have arranged them in increasing order, the smallest number first and the higher number, and so on. As we see, there is no middle number. So in this example, we will add up the 4th and the 5th value and divide it by 2. So basically, we are finding the mean or average of those two middle numbers, and this is how we get the median. Similarly, it is easy to find the median when there are odd numbers of data points. As I said earlier, when we are talking about the mean is affected by the extreme values. The median is not affected by the extreme values. Let's take the same example where instead of 18, the last item is 180. Now, even if this is 180, the median will still be the same because once you arrange them in the ascending order and takes the middle number, the median number will remain the same. So the median will not be affected by a few extreme values. Let us talk about the mode, which is the next measurement of central tendency. The mode is simply the number that appears most frequently in the sequence. For example, now let us take the numbers 10, 12, 18, 12, 12, 14, 16 and 10. Here you can see that 12 appears 3 times while other numbers appear once, or you can say less than 3 times. Therefore 12 is the mode for this sequence, since it is the most frequently occurring number. Let us consider a scenario where we have a multiple numbers with an equal highest frequencies. For instance, there could be two numbers that are the most frequent, like in this case we have 12 and 18. In such a situation, we may wonder which number is the mode. There are two possible ways to answer this question. Firstly, we can say that the set does not have a mode because there is no clear winner. This means that the set does not have a value that appears more frequently than any other values. Alternatively, some people refers to this set as bimodal, indicating the presence of two modes. Remember, so when two numbers occurs with the same frequency in a set, they are both considered modes. For example, in this set, 12 and 18 both occurs 3 times. So we say that this is a bimodal, meaning it has two modes. However, if the set has more than two values that occurs with the same frequency, it is important to note that we don't use the term trimodal or quadmodal or any other similar terms for this set with more than two modes. For instance, in the given set, 12, 14 and 18, each value occurs 3 times. So we only say it as bimodal or there is no mode. In summary, a set is a bimodal if it has two values that occurs with the same highest frequency. If there is no clear winner in the set, we say that the set has no mode. So I hope you have liked this video on measurement of central tendency. So in this playlist, we'll cover theory as well as practical using Python, and I will see you in my next video.